Hi, once again. So, like I said, on this video, now we are going to be focusing on the parabolic suspension. Or the parabolic caternary cables. If we let So, with this one, it's still the same thing. I will take the formulas from this book, of which you can screenshot. And from there, the questions that I will be doing are going to be based on the other textbook, Future Managers one. These ones, we still have banana, woody, and we still have the support A, the support B. So, when now they are of different heights, we still have OA and OB. We still have OA here, as well as OH there. And even fast. So, now, sometimes, on this parabolic ones, we are going to be having pulleys as well as trolleys. So, the difference now is that the difference between those ones and these ones is that these ones now, they have what we call an anchor cable. We are going to be having an anchor cable that side. So, you can call it an anchor cable or a backstay. So, this one here in between, this is the one that we are going to call the main cable. So, here we have the main cable. Then this side we are going to be having the anchor cable. Also this side, this one is what? It's our anchor cable. So for the main cable, I'm simply just going to use OM like that. Then for the anchor cable, I'm simply just going to use OA like that. So we have the main cable as well as the anchor cable. So the anchor cable, it can go through what we call a trolley, or it can go through a pulley. So, if there is a pulley, what does that mean? It means that now, FT, please note this, this you should know it. So, if it's a pulley, FT of your main cable is going to be equals to FT of your what? Of your anchor cable. FT main or FTM is going to be equals to FTA. Only if it's what? Only if it's a pulley. You will see how this comes in play. So, meaning that FH of your main cable is no longer equals to FH of your anchor cable. Then, on a trolley or on frictional rollers, you have rollers we have pulleys. So if they say rollers or trolley, this is what you are going to apply. FH of the main cable is going to be equals to FH of your anchor cable. And FT of your main cable is no longer going to be equals to FT of your anchor cable. This is for trolleys and this is for our pulleys. So the bending moment on a pulley is going to be equals to FH of your main cable minus FH of your anchor cable multiplied by H. Then the vertical thrust is going to be equals to your FV of your main cable plus the FV of the anchor cable. The vertical thrust can sometimes be called a reaction. So if they say calculate the reaction at support B, we will simply just add the vertical forces over. Then the resultant thrust is now going to be equals to the square root of FH main minus FH anchor cable, all that squared, plus the vertical thrust, which is FV main plus FV anchor, like that. Now let's move to our rollers. So if it's rollers or trolleys, in bending moment will always be equals to 0 here. Then the resultant thrust is going to be equals to FV of your main cable plus FV of your anchor cable. This. So if it's like this, meaning that it is also your what? Your vertical thrust. So meaning that if they say calculate the reaction on support B, you will use this. This is going to be the reaction on support B. Now let's take a question and see how this is going to come into play. We are going to go to page 78, exercise 2.2. There we are having a cable of a suspension bridge, which carries a load of 20 Newton meters, and the span of the bridge is 148. The length between the supports is 148. If the safe tension in the cable is 5 kilonewtons, calculate the minimum tension in the cable. So we have supports that are at the same height. Support A and support B. We are given the distance in between kilonewton. What is that? If they say tension of the cable, someone might say maybe it's FH. Someone might say maybe it's FT. So we are not sure, right? But remember, coming from N5, they save stress. If they say save stress, it means that that is the maximum stress, because once you exceed that, it means that that thing is going to fail, right? Or that beam is going to fail, or that member is going to fail. So also here, save stress, it means that it is your what? Your maximum tension. Sorry, save tension. It means that is your what? Your maximum tension. That's why the first question is saying calculate the minimum tension in the cable, not at the support. Right? In the cable. So if it's in the cable, it means that they want you to calculate OFH now, given that you have one OFT. So I always do this. Right? So I want to find FH. I have FT. What do I know about FV? FV is equal to WN divided by 2. So meaning that FT is going to be equals to, let's say FT squared is going to be equals to FH squared plus FV squared. We want to find FH. So FH is going to be equals to the root of what? Of FT squared minus what? Minus FV squared. Then, what is OFT? OFT, we just said that this was our 5 times 10 to the power of 3, all this squared, minus OFV. FV is equal to what? All this divided by 2. Right? So, n divided by 2 is equal to what? X, so, our W, it is what then? It is given to you that it is 20 multiplied by 148, all this divided by 2. So, this comes from the formula of what? FV is going to be equal to WX. So, this is the same thing. X is equal to n over 2. So here I'm going to put 20 multiplied by 148, all this divided by 2, all this squared. And here you are going to get the root of 5 times 10 to the power of 3, all this squared, minus 20 multiplied by 148 divided by 2, this squared. You get to FH is 4775,994 newtons. Then 1.2 says calculate the sag in the cable. You want to calculate the sag in the cable. So there is this formula that says FH is going to be equal to what? W n squared, all this divided by what? We have FH much. We have N, we have W, we want to put D, right? So FH is what? Is 4775. maximum slope. Right? Remember with FT and FH, we want it. So this is adjacent and this is hypotenuse, right? So cos. So cos of theta is going to be equal to our adjacent, which is FH 477. 5.94. All this divided by our hypotenuse, which is 5,000. And then that's we are going to get our eta, that is equals to 70.21. Then the last question is saying what's the length of what? Of the cable, right? So the length of the cable is equals to L plus 8D squared, or this divided by what? By 3N, right? Now that you have OD, you can find below. So this is 148 plus 8 multiplied by 11, 466 squared, or this divided by 148. So 148 plus 8 multiplied by 11, 466 squared, divided by 3 multiplied by 148. Here we get the end of the cable, that is 150,369. Remember, the length of the cable is what equals to the span, or the distance in between. The length of the cable is always supposed to be bigger than the span initially. Okay. So this was what? This was number 1. So we are going to also get number 2. So number 2 is saying the cables of the suspension bridge are suspended between two supports that are 120 from each other. So the span or the distance between the supports is 120. And the difference in height between the two supports is 7 meters. The sag of the cable is 9 meters below the shortest support. And the bridge carries a load of 7 kilonewtons meters. Calculate the maximum and minimum tension in the cable. So we want to calculate one OFH as well as OFT. Remember, if you have any questions, you can comment on the comment section below. So I'm used to drawing this because it gives me a clue of what am I supposed to do next. I remember we leave it set somewhere. So we start with 120. And then the next one is the 7. And the next one is 9. Right? So you want to calculate the maximum and minimum tension in the cable. So let's start by first finding one You can check on the screenshots of the formulas. You will see that all the formulas that are there, they have x. So for you to be able to find FT, you need to find OFH. And all the formulas of what? Of FH and 1 and x. So the first thing that we are going to do here, we are going to find OX. So what do we know? We know what's in the main table. In the main table, FH is equal to FH, right? And you have two formulas of calculating one FH. So meaning that you can say FH is going to be equal to FH. And then this is now going to be equal to what? WX1 squared, all this divided by 2b, and this is going to be equals to W into what? L minus x1 all this squared divided by 2 into d plus h. So here we want to solve for 1 xy so that we can be able to find OFH. Then with FH we can solve using the triangle of forces to find 1 OFT. So we have W over 2, we also have W over 2 this side. So let's simply just do this so that we can be left with what? X1 squared plus divided by b. This is going to be equals to a minus x1 squared plus divided by b plus d plus h. Then let's substitute. We do not have x1, right? But put d way to is equals to 1, 9. This is going to be equals to a way to go 120 minus x1 squared multiplied by 9 plus 7. Then I'm going to say now 9 plus 7 divided by 9. Until 1, 7, 7, 8. x1 squared, this is going to be equals to 120 minus that, minus x1 squared. Then I put a square root on both sides. So, what is the square root of 1.778? It is 1, 3, 3, x1. This is going to be equals to 120 minus x1. Then x1 goes that side. It's going to be 2.3, 3, x1. This is going to be equals to 120. For 120 divided by 2.33, we get to x1 is equals to 51.4346 meters. Right. So now that we have 1 OX1, OX1 OOP now. I'm sure will be that means this is 1 and this is 2, right? So the distance from here to there, it is 51.436. Never say the distance from here to there, it is equal to 120 divided by 2 dot. So meaning that the distance from here to there, it is going to be equals to 120 minus 51.436. We are getting 1 here. It is going to be equals now that we have this, we can now start answering. Now that we have this, we can now start answering the question. So, I'm going to read the statement again. The cables, not the cable. Check, if you check number 1, it said the cable. Number 2 is saying the cables. So if there were 3 cables, we were going to be told that there are 3 cables or 4 cables. But if it says the cables, we are always going to assume that there are 2 cables that we are talking about. So the cables of a suspension bridge are suspended between 2 supports which are 120 from each other, and the difference in height between the 2 supports is 7. The sag of the cables is 9 meters below the shortest support. Remember, always there's the sag, you always measure it from the shortest support. Unless both of the supports are equal, that's when you can simply just take the sag as it is. Then the bridge carries a load of 7 kilonewton meters, that is W. Then they say calculate the maximum and minimum tension in the cable. We are having cables, but we want per cable in the cable. So, for both cables now, FH is going to be equals to WX1 squared all this divided by 2D. You can even use the other formula, which is this one. You'll still get the same answer. So we are simply just using this one because it's the simplest. So we are having 7 times 10 to the power of 3 multiplied by x1 over 51,436 squared. All this is going to be divided by 2 multiplied by 9. This is for both cables. 7 times 10 to the power of 3 multiplied by 51,436 squared. All this divided by 2 multiplied by 9. You get what for all cables. This 1, 0, 2, 8, 8, 6, 8, 5, 9, 8 newtons. Right? Then let's take it to our meganewtons. It's going to be 1,0229 meganewtons. This is for both cables, right? The question said per cable. So it means that I'm going to divide this answer no 1, no 2. So if you divide the answer by 2, we get to per cable we have 514, 434 kilonewtons. This is what you should be getting. Kilonewtons. If you have questions. Right. So now that we have FH, remember we want the maximum and minimum tension in the cable, right? So between this one and this one of them is maximum. Is maximum, right? So we want to find the FT this side, not this side, because the FT that is here is going to be smaller than the FT that is there. So let's find the FT that is there. On our triangle of forces, we said that FT at B is going to be equals to the root of what? Of FH squared minus, I'm sure we have FH much. So minus what? Minus FB squared. Or plus, sorry. It's Pythagorean. Hypotenuse is equals to whatever. So, what is OFB going to be like? OFB is W into what? Into N minus what? Minus x1. All this is going to be what? All this is going to be squared. Or, if you do not want to say this, you can say now. Because you already solved for the integration. You can say W multiplied by XB, which is this one. A1. So all this is going to be square dimension. So our FH is what? It is 514. Okay. So let's calculate for both cables and we'll divide the final answer. Okay? For both cables, FT is equals to, or FH is equals to 1,029 times 10 to the power of 6 squared plus into 7 times 10 to the power of 3 multiplied by 68,564 all this squared. Here we are going to find FT for both cables. I took it to megajoults. I'm getting 1,135 meganewtons. This is for both cables and a cable. I'm getting 5, 6, 7. This is what I'm getting. 2.2 says the distance from the longest support where the tension in the cable is 550 kilonewtons. So now let's continue with number 2. So the distance from the longest support where the tension in the cable is going to be what? 550. So somewhere along the cable there, the tension is going to be what? 550. So just like the previous one where we labeled this point here OZ. So we treated it like here, there is a support somewhere there, and we want the distance here, which is, we call it 1 exit, right? So now we also had this distance here, and we call it what? XOZ. So we are going to start by first finding XOZ, and then after that we are going to solve for XZ. So what did we do last time? We drew the triangle of forces, right? Like this. So from our triangle of forces, we have FT here, we have FH here, and we also have FV there. So from here, we have one FH, right? We also have one FT. Remember, our FT is equal to 550. Now, we no longer like FT because we are talking about this point here. So at this point, FT 550. Do not use the other FT. Okay? So on this topic, we are saying that FV is equal to what? WXOZ. So FT squared is going to be equals to the root of what? The root of FH, sorry, is going to be equals to FH squared plus FV squared. Then we solve for FV. We make FV the subject of the formula. You will find that FT squared minus OFH squared, all this divided by OW. This is going to be equals to what? X opposite. Right. But now, it said also here on number 2, in the cable. So once it says in the cable, W of the cables is 7, right? We want in the cable W is going to be equals to what? It's going to be equals to 3.5 kilonewtons meters. Then, now, let's substitute here and find our X, O, Z. So, we're having FT that is equals to 550. 550 times 10 to the power of 3 squared minus our FH, which is 514 times 10 to the power of 3 also squared. All this is going to be divided by 3.5. This is going to be equals to what? XO, XOZ. Then we find XOZ to be equals to what? This is what? 55,542 meters. This distance from here to there, it is 55,542. Now we can now solve for this one. Therefore, XZ is going to be equals to 68,564 minus 55,542. Then here you are going to get 68,564 minus 55,542. You are getting 13,022 meters. Right. This is the distance from the lower support to where the tension is equals to 550. Now let's look at 2.3. 2.3 says, the reaction in the longer support, if the cable goes over a pulley and the angle between the anchor cable and the support is 65. We are talking about a pulley. There is a pulley here where the cable is going to go over before it comes to being the cable, to the anchor cable this side. So, here, what do we know? We said if it's a pulley, it means that FT of your main cable is equals to FT of your anchor cable. So you have OFT here that is going to be equals to the FT of your anchor cable. And we said that's the FT of the anchor cable. We found it to be what? 567,5. Right? So you also have this angle here that it is 65. Here you have FH. So we do not have the value of FH. Why? Because we know the FH of the anchor cable is not equals to FH of your anchor cable if it's a pulley. Then in a pulley, what is it that is equal? It's FT. So you have FT. You have an angle. What are you looking for? You are looking for FV of your anchor cable, as well as you are also going to solve for FV of your main cable. Then this is what you are going to be adding for 2.3. So we are looking for what? The reaction. So let's start with the anchor cable. On our anchor cable, we are having a hypotenuse, we want the adjacent. I always do this so I don't make mistakes. I have hypotenuse, I want adjacent, that is cos. cos of 65 is going to be equals to my adjacent, which is 1 FV of my anchor cable, FVA, all this divided by my hypotenuse, which is 567, what? 5. Then I find FVA to be equals to you will get 239.835. Then we come to solving for the main cable. So for the main cable, on the main cable, we solved for FH, symptomatic to 514.5, and we also have for FT. FT doesn't change, so it is 8567.5. So for now, FV of the main cable. So by that, we're going to do right here. So FT squared is going to be equals to FH squared plus FV, FVM squared. That's FVM. So it's going to be equals to the root of FT squared minus FH squared. Here we will find FV. Is 567.5 squared minus FH 514.5 squared. Here, kilonewtons. Remember it's kilonewtons because I didn't convert this one, right? So what is the root of 567.5 squared minus 514.5 squared? Here you are going to get 239.47 kilonewtons. Therefore, the reaction at E is going to be equal to 239.835 plus 239.47. So here you get what? You get 479.305 kilonewtons. This is the reaction if it's a what? If it's a Pulley. Let's go to 2.4. Calculate the reaction in the support if the pulley is now replaced by frictionless rollers. Right? So, before I erase here, this angle here, you were not given, even from the original statement. So never assume that this angle here is equals to the angle here of your main cable. This is the main cable, right? This is the triangle of forces for the main cable. Then this is the triangle of forces for the anchor cable, right? So never assume that the angle here that you are given on 2.3 it is equals to these two angles are equal. Never. That's why I solve using Pythagorean theorem. It's because the angles are not equal. If I was given the angle of the main cable, I would solve using the trigonometric ratios. Now, we want to find the reaction in the support if the pulleys are replaced by frictionless rollers. So we are not changing the angle, we are simply just changing this system. Instead of a pulley, we are now putting frictionless rollers or a trolley. So if it's a trolley, what is equal now? FH, right? So never assume also that this angle and this angle they are equal. Remember, this is the triangle of forces for the main cable, and this is the triangle of forces for the anchor cable. So never assume that this angle and this angle they are what? They are equal. Okay? So now we want to find FV of our anchor cable. I'm not going to solve for the FV of the main cable because it's not going to change. If these two values are not changing, FV is 239, 915 plus 239, 447, 13, 479, 1385. This is for when instead of a pulley, it's a roller. So we are using 1 FH. If it's a pulley,